So here's our interactive integral graphing calculator. So here we have a nice grid that we can move around, we can zoom in, do whatever we want, and here we can input any equation we want, just like functions like a normal graphing calculator. So let's take x, or x squared. Here we have x squared, works nice and dandy. How we made this was using C++ and SFML, and we plotted basically multiple points for the graph, that about 100 points that you see right now, and then there are lines being drawn in between them. But so the more, every time we move around, every time we zoom in, it's constantly replotting and regraphing everything, so it looks, and it looks seamless. Again, a little lagging on my computer. No, that's more of a client side thing, but we can do any graph here: x squared, x to the x squared. We could do sine of x. Pretty much everything works here. But the reason we call this an integral calculator specifically is because we have this special feature, so we can add the bounds of the that we want for the integral. So let's take -3 to 5, and you can already see that it is currently displaying the actual area under the curve. And on the bottom left here, we get the actual area of it. Obviously, right now it's negative because there's more negative area than positive, because we're not doing absolute value. If we wanted to do absolute value, unfortunately, we didn't have time to add to use a symbol for absolute value, because that's a lot of parsing work. So I'll just retype this here. Just do ABS sine of x. Here we should get the actual approximate area, because basic calculus, you guys should understand. So yeah, and you can do this for pretty much any graph that works on this. So we can do tangent of x. Looks very cool. All of these are basically just basically lines that are being graphed using a triangle split. We could do sine of, oh no, that's not parentheses. Sine of x to the x squared. All works nice, fine, and dandy. We could always change the bounds. So we could do this to like -10, and do this. You go just like 6. Oh, can't type 6. Yeah, and it changes the bounds live. Obviously, the more lines that there is, the laggier it gets. But again, so some of the features that we can add is better type, but easier to type on the equation line. This is very heavily inspired by Desmos. Desmos obviously is very simple to type on it for equations, with it automatically registering certain symbols or certain phrases into functions, like such as typing pi would turn into pi, or e. Currently we have pi. Pi does work. E doesn't. Like I said, absolute value, you have to put them in parentheses like that. Things like that. Just is a quality of life for the user. Another thing we hope to implement is better optimization. Obviously, as you can see, when we built this on a different computer, this worked very well, but right now, it's quite laggy. So optimization is something we do hope to add in the near future, though it doesn't seem like with the time constraints we'd be able to do that. Another thing is just better UI. It's a little sloppily done, especially with the miscoloring, but these are all basically quality of life. Most of the functionality does work, and it works pretty well. Especially completely built. This is completely built from the ground up. Like I said, everything had to be built. Even just moving around was already a challenge in of itself. It's just basically just moving a bunch of vertices, a bunch of lines over by a certain measurement. It's just a lot of mathematics. But that's under the wave for you. You can probably tell where the name comes from. We're calculating the area under the wave. In this case, a sine wave. I don't know. That's the program. I hope you guys enjoyed it. Thank you for watching our demonstration, and hope you vote for us. Thank you.